Hello and welcome back at the FinetLink channel. So after we are done with VLAN and inter-VLAN routing, now we will go in a new concept which will be the spanning tree protocol. A well-designed layer 2 network will have redundant switches and paths to ensure that if one switch goes down, another path to a different switch is available to forward data. Users of the network would not experience any disruptions of service, but even the redundancy in a hierarchical network design fixes the problem of a single point of failure, it will create a different kind of problem that is called layer 2 loops. A layer 2 loop can happen very quickly and make it impossible to use the network. There are a few common ways that a layer 2 loop can be created and propagated. Spanning tree protocol is designed specifically to eliminate layer 2 loops in the network. And here we will discuss the cause of loops and various types of spanning tree protocol. So we will explain how spanning tree protocol enables redundancy in a layer 2 network. So we will explain common problems in a redundant layer 2 switch network, and we will explain how spanning tree protocol operates in a simple switch network, and then we will see the evolution of spanning tree protocol. So in the first video, we will explain the common problems in redundant layer 2 switch network, and the other two topics will be explained in further videos that will be uploaded later. So the topics about the purpose of spanning tree protocol covers the cause of loop in a layer 2 network and briefly explain why spanning tree protocol works. Redundancy is an important part of the hierarchical design for eliminating single points of failure and preventing disruption of network services to users. And redundant network require the addition of physical path, but logical redundancy must also be part of the design. Having alternate physical path for data to traverse the network makes it possible for user to access network resources despite the path disruption. But, however, this redundant path in a switch Ethernet network may cause both physical and logical layer 2 loops. Because the Ethernet LAN requires a loop-free topology with a single path between any two devices, and a loop in Ethernet LAN can cause continued propagation of Ethernet frames until a link is disrupted and breaks the loop. So the spanning tree protocol is a loop prevention network protocol that allows the redundancy while creating a loop-free layer 2 topology. So here you can view an animation of spanning tree protocol in action, and it is explained step by step. And as you can see, by this, it will eliminate the loops. And here, if we see this video, we'll see the animation of spanning tree protocol recalculating the road when we have a failure. So as you can see, the link between switch 2 and switch 1 have failed. So the spanning tree protocol will find another way to send the data to the destination. And remember that the loops happen at the layer 2 switch network. A path redundancy provides multiple network services by eliminating the possibility of a single point of failure. And when multiple paths exit between two devices on an Ethernet network and there is no spanning tree implementation on the switches, a layer 2 loop occurs. A layer 2 loop can result in MAC address table instability, link saturation, and high CPU utilization on switches and end devices, resulting in the network becoming unusable. Unlike the Layer 3 protocol IPv4 and IPv6, Layer 2 Ethernet does not include a mechanism to recognize and eliminate endlessly looping frames. Both IPv4 and IPv6 include a mechanism that limits the number of times a Layer 3 networking device can retransmit a packet. A router will decrement the time to leave in every IPv4 packet and the hop limit field in every IPv6 packet. When these fields are decremented to 0, a router will drop the packet. Ethernet and Ethernet switches have no comparable mechanism for limiting the number of times a switch retransmits a layer 2 frame. And so the spanning tree protocol was developed specifically as a loop prevention mechanism for layer 2 Ethernet. Without the spanning tree protocol enabled, layer 2 loops can come from causing broadcast, multicast, and a non-unicast frame to loop endlessly. This can break down a network within a very short amount of time, sometimes in just a few seconds. For example, a broadcast frame such as an IRP request are forwarded out all of the switch ports except the original ingress port. This ensures that all devices in a broadcast domain are able to receive the frame. If there is more than one path for the frame to be forwarded out, an endless loop can result. When a loop occurs, the MAC address table on a switch will constantly change with updates from the broadcast frames, which result in MAC database instability. This can cause high CPU utilization, which makes the switch unable to forward frames. And broadcast frames are not the only type of frames that are affected by the loops. Even a non-unicast frame sent onto a loop network can result in duplicate frames arriving at the destination device. A non-unicast frame is when the switch does not have the destination MAC address in its MAC address table and must forward the frame out all ports except the ingress port. And here there is an animation to see how the loops will be caused by the broadcast. So you see that the switch 2 updates the MAC address table referring the mapping from the PC1, and then it will broadcast out all ports except the receiving port. And now you will see that the switch 3 and switch 1 will update their MAC address table for the PC1, and then they will forward broadcast out all ports except the receiving port. But what will happen? Switch 1 and switch 3 receive a packet from the PC1 on a new port, so they have to update the MAC table and send it out of all ports except the ingress port. So the switch 2 now got a frame for the PC1 from a different port, and now he will update his MAC table. And he will frame the broadcast out of all ports except the last receiving port. And this is how the cycle starts again. And by this, it means that it enters in a broadcast loop and will make the CPU utilization of the devices very high and cannot make the switch to enable forwarding the frames to the destination. So it ends in an endlessly loop. A broadcast storm is an abnormal high number of broadcasts overwhelming the network during a specific amount of time. Broadcast storms can disable a network within seconds by overwhelming switches and devices. Broadcast storms can be caused by a hardware problem such as faulty network interface card or from a layer 2 loop in the network. Layer 2 broadcasts in a network such as an ARP requests are very common. A layer 2 loop is likely to have immediate and disabling consequences on the network. Layer 2 multicasts are typically forwarded the same way as the broadcast by the switch. So, although IPv6 packets are never forwarded as a layer 2 broadcast, an Internet Control Message Protocol version 6 neighbor discovery use layer 2 multicast. And here in this animation, you can see the increasingly adverse effects of a loop as the broadcast and non-unicast frames continue to propagate indefinitely in a broadcast storm. So PC1 will forward the broadcast that gets caught in a layer 2 loop. It's what we explained before. And look what will happen. Now it's a PC3 and then it will be the PC number 2. And look at all those frames that are in the switch, making the broadcast frame to not be processed due to the traffic overloaded on the network. A host caught in a layer 2 loop is not accessible to other hosts on the network. Additionally, due to the constant changes in its MAC address table, the switch does not know which port to forward unicast frames. In the previous animation that we saw, the switches will have the incorrect port listed to the PC1, but any unknown unicast frame designated for the PC1 loops around the network, just as the broadcast frames do. More and more frames looping around the network eventually create a broadcast storm. And to prevent this issue from occurring in a redundant network, some type of spanning tree must be enabled on the switches. Spanning tree is enabled by default on Cisco switches to prevent layer 2 loops from occurring. A spanning tree is based on an algorithm invented by Radia Perlman while working for Digital. So it was invented by Radia Perlman while working for Digital Equipment Corporation and published in the paper of an algorithm for distributed computation on a spanning tree in extended line. Her spanning tree algorithm, which stands for SDA, creates a loop-free topology by selecting a single root bridge where all other switches determine a single least cost path. And this is a spanning tree algorithm canary topology, which uses an Ethernet LAN with redundant connection between multiple switches. And as you can see, there are around 8 switches connected together. So the spanning tree algorithm begins by selecting a single root bridge. Here in this figure, it shows that switch 1 has been selected as the root bridge. And in this topology, all links are equal cost. We have the same bandwidth. Each switch will determine a single least cost path from its edge to the root bridge. And then the spanning tree protocol ensures that there is only one logical path between all destinations on the network by intentionally blocking redundant paths that could cause a loop, as it is shown here. When a port is blocked, user data is probably leaving that port. Blocking the redundant path is critical to prevent loop on the network. A blocked port has the effect of making that link of non-forwarding link between the two switches, as it is shown here. By this, we create a topology where each switch has only a single path to the root bridge, similar to branches on a tree that connect to the root of the tree. And as you can see, each switch now has just one forwarding path to the root bridge. The physical path still exists to provide redundancy, but these paths are disabled to prevent the loop from occurring. If the path is ever needed to compensate for a network cable or switch failure, spanning tree protocol recalculates the paths and unblocks the necessary ports to allow the redundant path to become active. Spanning tree protocol recalculation can also occur anytime a new switch or a new inter-switch link is added to the network. And here in this figure, it shows a link failure between switch 2 and switch 4, causing the spanning tree protocol to recalculate. Notice that the previously redundant link between switch 4 and switch 5 is now forwarding to compensate for the failure. This is still only one path between every switch and the root bridge. The spanning tree protocol prevents loops from occurring by configuring a loop-free path through the network using strategically placed blocking state ports. The switches running spanning tree protocol are able to compensate for failures by dynamically unblocking the previously blocked port and permitting traffic to traverse the alternate paths. And that was all about the spanning tree concept and the purpose of using the spanning tree protocol. In the next video, we will see how the spanning tree protocol will elect the root bridge, how we will elect the root ports, a designated port, and elect alternate blocked ports. So be with us and for the new video that will be uploaded. And if you are new at this channel, do not forget to subscribe and hit the notification button for the new videos. And if you like the video, share it with your friends. See you soon.